An electron with a charge of negative 1.6 times 10 to the power of negative 19 coulomb is moving eastward into a magnetic field of strength 1.5 times 10 to the power of negative 5 Tesla, acting into the page, as you see here. If the magnitude of the initial velocity is 2 meters per second, what is the magnitude and direction of the force the electron initially experiences as it enters the magnetic field? So magnetic velocity is going this way, and magnetic field is into the page. We need to find out the magnitude and direction of the force. How to find out the magnitude of magnetic force is F equals to B times V times Q times sine theta. B is the magnetic field strength, which is given as 1.5 times 10 to the power of negative 5 Tesla. V is velocity, which is given as 2 meters per second. Q is charge of this electron, and it is 1.6 times 10 to the power of negative 19. And sine theta, theta is the angle between velocity direction and B direction, the magnetic field direction, which in this case they are perpendicular. So theta is 90, sine theta will be 1. That's how we calculate it. So now let's find a value. Let's do it without using the calculator. Let's make it a little bit challenging. 1.5 times 2 will be 3. 3 times 1.6 will be 4.8. Because 3 times 16 is 48, so 3 times 1.6 will be 4.8. Then 10 to the power of negative 5 times 10 to the power of negative 19 will be 10 to the power of negative 24. And the unit is Newton. That's how we calculate it without using the calculator. And let's find out the direction of this magnetic force. We need to use the right hand rule, but we need to be careful that we are talking about an electron, negative charge. So when we are using when we have positive charge, we need to use the right hand rule. So thumb is going the same as velocity. 4 fingers going toward down, which is B. And if you do it the same thing, palm is gonna show you the direction of the magnetic force, which is gonna be something like that. Thumb is like that, and it's gonna be like that. So your palm is gonna show the, actually I did it the other way around. Velocity is gonna go this way, thumb, and 4 fingers into the page. So in that case, force is gonna go up. My drawing is not really good. So force is going up if we are dealing with a positive charge. But now we are dealing with a negative charge, so it's gonna go exactly on the opposite side. So I'm gonna show it with blue. So force is gonna be going down. So one more time, thumb is gonna go toward velocity, 4 fingers toward B, magnetic field, and then your palm is gonna show you the force direction if we are dealing with a positive charge. But since we are dealing with a negative charge, we need to make it the other way around. Or for negative charge, you need to use the left hand instead of right hand. We can use any of these two methods. So that's going south. Force is gonna go south. And then what else we need to find? What is the magnitude and direction of the force electron? That's it. So we found the magnitude and we found the direction.